Hello and welcome back to another video. In this problem, we're asked to simplify the expression sine of 2 arc cosine of x. So I'm going to write this as the inverse cosine function because I think that'll be a little bit clearer. I'll rewrite it again as arc cos at the end just because that's what the problem wants. But we have sine times 2 times the inverse of cosine of x. And we're going to say, let's let y equal the inverse cosine. Therefore, this is equal to sine of 2 times, we just said, y. And we can use a trigonometric identity, which states that sine of 2y is equal to 2 sine y cosine y. Now we can plug back in y. So this is 2 times sine of cosine inverse of x times cosine of cosine inverse of x. Plugging back in cosine inverse for y. The sine of the inverse cosine of x is equal to the square root of 1 minus x squared. If you're wondering how I know that, it's because in problem 69, 3 problems ago, I just proved that the cosine of sine inverse of x equals the square root of 1 minus x squared. And if you want to understand how to do this proof, you can go back to that problem. But the same exact proof applies for sine of cosine inverse. Just when you go back to that problem, which I actually have right here, instead of subtracting sine squared at this point, you have to subtract cosine squared, but the rest of the proof remains the same. You get the same exact answer at the end of the day, square root of 1 minus x squared. So go back to this problem if you want to understand this. But if you just want to plug it in, that's fine. And then cosine of cosine inverse of x is just x, right? The function of its inverse is just the thing itself. So this is equal to 2 times x times the square root of 1 minus x squared. This is your final function. So sine of 2 arc cos of x is equal to 2 times x times the square root of 1 minus x squared.